Hey everyone, and welcome back to The Explainer. Today, we're tackling a massive, honestly incredibly costly problem that's plaguing almost every single industry on the planet right now, and that is the slow, manual, and highly error-prone delivery of software. If you've ever wondered how the tech giants push out hundreds of updates a day without breaking a sweat, while other companies literally struggle for months just to release a single minor feature, well, you're in exactly the right place. We are going to unpack the exact technical and cultural shifts that make that high-speed delivery possible. But first, I really want you to consider this frankly staggering number, $2.08 trillion. According to data from Duplo Cloud, that is exactly how much poor, inefficient software cost the US economy in the year 2020 alone. That's trillion with a T. We aren't just talking about a few annoying bugs here. We're talking about massive inefficiencies stemming from human error, resource bottlenecks, and those incredibly slow manual deployments. Businesses are bleeding over $1 million a year just from these bottlenecks. So, how do we stop the bleed? Well, that's exactly what we're here to figure out. Okay, let's dive right into this. Here's our roadmap for today. First, we'll be demystifying DevOps. Then, we'll look at the DevOps lifecycle, followed by a real-world pipeline demo. After that, we'll cover pitfalls and best practices, check out the tool ecosystem, and wrap it all up with a quick recap.
All right, Section 1, Demystifying DevOps.
So, what does this massive buzzword actually mean in everyday terms? Well, to really get DevOps, you have to look at the old, rigid, waterfall way of doing things. Back then, development teams and operations teams were totally siloed. Developers would write the code and basically just hurl it blindly over the proverbial wall to operations. The ops team was then stuck trying to figure out how to manually configure servers and actually deploy the thing. It was slow, it was rigid, and man, it was full of friction. The new way, the DevOps way, completely changes the game. It brings those teams together using automated CI/CD, or continuous integration and continuous deployment, to make releases rapid, frequent, and super reliable. To put a formal definition on it, DevOps is a cultural and technical model that combines development and operations to deliver software rapidly and reliably through automation. Think of it kind of like a highly efficient modern manufacturing assembly line, but for code. It takes those repetitive, manual, button-pushing tasks away from humans and hands them over to automated computer systems. That means your engineers get to actually focus on creativity and problem-solving rather than manually configuring a server for the 100th time. Moving right along to Section 2. The DevOps lifecycle. Let's see how this actually builds. How does software move through this modern assembly line? It happens across 6 distinct stages. First up, we plan, where we define requirements and break work down using tools like Jira. Next is code. Developers write the software and use version control like Git to track all their changes. Then comes build, where the code is automatically compiled and packaged into deployable artifacts. Right after that, we test, and this is absolutely crucial. Automated tests check for bugs and security risks. Once it passes, we deploy to production using strategies that basically guarantee zero downtime. And finally, we monitor. We're continuously watching logs and metrics to ensure availability, and here's the magic. We feed that data right back into the planning stage. It's this endless, continuous loop of improvement. Which brings us to Section 3, a real-world pipeline demo. Okay, so how does this actually look in practice? Let's imagine a scenario where a developer just finished writing a cool new feature. Step 1, the developer pushes their code to a shared Git repository. In the old days, they'd probably have to Slack or email an ops manager saying the code is ready. Not anymore. In our DevOps pipeline, this simple code push acts as the trigger. It automatically kicks the entire assembly line into gear. Literally, no one has to click another button. Now, what's really interesting here is this continuous integration phase, which acts as a built-in automated safety net. A tool like Jenkins, for example, instantly detects that new code was pushed. It automatically triggers a build, compiles the code, and right away runs a whole suite of automated unit and integration tests. If the developer made a typo or broke something, Jenkins catches the bug instantly, stops the pipeline, and alerts the team. If it passes, it moves straight to the next phase, again, with zero human intervention. And this brilliantly illustrates the deployment phase. Once it's tested, a tool like Docker packages the application and all its dependencies into a single container. That guarantees that if the code worked on the developer's laptop, it's going to work the exact same way in production. Then, a container orchestration tool, usually Kubernetes, takes over.
It safely deploys that container to the live servers, automatically scales it up if traffic spikes, and handles load balancing. You literally go from a code push to a live feature in minutes.
The real-world impact of this kind of automation is just staggering. Take Geeks for Geeks as an example. By fully adopting a DevOps mindset and moving away from their old, inefficient setups, they saw a massive 70% decrease in their AWS cloud infrastructure costs. 70%! That is a game-changing amount of capital freed up simply by working smarter and letting automation do the heavy lifting.
So how exactly did they slash those massive cloud bills? Well, first, they ditched the pricey AWS Elasticache and hosted open-source Redis on their own instances. Boom! That cut costs by 60 to 70% right there. Second, they optimized their huge video delivery platform by bringing in Amazon CloudFront for edge caching. That dropped bandwidth costs by up to 70% and made videos load way faster for their users everywhere. And finally, they used some really smart, simple automation. A script that literally just turns off their dev and test servers at 10 p.m. and turns them back on at 9 a.m. That one script saved them 50% on development compute costs because, they stopped paying for machines no one was using while they were asleep.
Let's shift gears a bit. Section 4, Pitfalls and Best Practices. Look, transitioning to DevOps takes real work. It's not all sunshine and magically lower cloud bills. So I want you to think about this. What do you think are the most common mistakes beginners make when trying to adopt DevOps? A lot of people think you can just buy a bunch of shiny new tools and fix everything. But tools alone do not fix bad processes. If you just automate a broken process, you're really just getting a broken result, just a whole lot faster.
Let's map out exactly what to avoid. A huge pitfall is continuing to rely on manual server configuration. That's a one-way ticket to inconsistencies and system crashes. The best practice here is infrastructure as code, or IAC. You basically define your servers in version-controlled scripts. Another really dangerous trap is waiting to test security at the very end of the line. That causes massive delays and vulnerabilities. The industry standard now is DevSecOps. You shift security left, meaning it happens continuously throughout the entire build pipeline. And lastly, running unoptimized, always-on cloud instances will absolutely drain your budget. The fix? Implement auto-scaling infrastructure that dynamically grows and shrinks exactly according to your actual real-time workload.
All right, moving to Section 5, the tool ecosystem. Now, to actually execute all these best practices, you're going to need the right tools. We can break this massive ecosystem down into a few essential buckets. For continuous integration and delivery, you'll want to familiarize yourself with platforms like Jenkins, GitLab CI, or GitHub Actions. For packaging and actually running the code, the containers and orchestration space is totally dominated by Docker and Kubernetes. When you want to spin up servers using scripts, that's our infrastructure as code. Terraform and AWS CloudFormation are the heavyweights. And finally, monitoring and observability. Tools like Prometheus, Grafana, and Datadog are essential. They give you those real-time dashboards and alerts you need to catch issues way before your users ever notice them. Okay, we've covered a ton of ground today. Section 6, quick recap.
So the absolutely crucial point here is that DevOps is not just a tool you buy. It's a completely new way of operating. If you only take away a few things from this explainer, remember these core principles. 1. Break down those silos between your dev, ops, and QA teams. 2. Automate absolutely every repetitive task you can using a CI/CD pipeline. 3. Use infrastructure as code to keep your testing and production environments perfectly synced. 4. Shift your security left, bringing it in early to create DevSecOps. And 5. Continuously use smart automation and monitoring to optimize for both scale and cost.
And that wraps up our journey through the modern software assembly line. If this explainer helped demystify DevOps for you, please hit that subscribe button. And hey, I really want to hear from you. Drop a comment below and let me know, what is your biggest DevOps bottleneck currently? More importantly, I challenge you to go out there and try setting up a basic automated pipeline yourself. The tools are out there, a lot of them are totally free and open source, and the power is quite literally at your fingertips. So the only question left is, what are you going to automate first? Thanks so much for joining me, and I'll catch you in the next explainer.